Homework video for Chapter 9, Lesson 2, Quadratic Transformations and the Vertex form. Quick review of transformations that we did in class. There are 4 transformations to a quadratic graph. There's a translation up or down, which is determined by the k value in vertex form. There's a translation left and right as determined by h. There's a dilation, which goes from narrow to wide and everything in between, but either a narrowing or a widening dilation, and that's based on the value of a. Reflection is when a is negative. So in our first part of the homework on page 577, number 1 through 6, we are to identify the transformations present in the equation. And so for number 1, we have negative 11. So this is you can abbreviate as well. This is a translation down 11 units. Number 2 has 2 transformations. This 1/2 is a dilation that widens, and the 2 is going to be a translation that shifts it right 2. Number 3 has 2 transformations. The negative a value is going to be a reflection, causing the graph to flip down, and the positive 8 is going to be a translation up 8 units. On number 4, we have 1 transformation. The number 6 is going to be a dilation narrow. Number 5, there are 3 transformations. The negative is going to be a reflection. The negative on the a value. The negative specifically when a is negative, that's the reflection. The 4, when a is 4, that is going to be a dilation narrow. And lastly, this base equation is x minus h, so that means this is a translation left 3. And then number 6 has 2. There's a reflection because a is negative, and then there is a translation that's right 2. On to part 2. Part 2 is going to be writing an equation in vertex form given a vertex coordinate and also a point. And I chose 3. This is a pretty odd appearance. I was going to do, I think, 20 through 23. However, 21, 22, and 23 were awkward, undesirable fractions. So I chose 3. Number 8 has fractions, but it's mild, and they end up canceling. So that there is a benefit to the jumping around. All right, number 20. We have a vertex of negative 2, negative 2. We have a point on the graph. Hang on a second, I need to move locations. We have number 20, we have a point on the graph that is -4, -10. We're going to use the vertex form of an equation. You should write this out as well because this helps you to memorize it, and yes, you need to memorize it. All right, we're going to substitute values, so you should absolutely label this to help you. The vertex coordinates are h and k. A point on the graph is x and y. So we're going to substitute these 4 points into this equation and solve. So y is -10. We don't have a value for a. We're going to do all this in order to solve and find out what a equals for this equation. X is -4. H is -2, so that's -2. K is -2. And now we're going to do the math and solve for a. So -4 plus 2 is going to equal -2, and the -2 squared equals 4. I'm going to add 2 to both sides. Divide by 4. A is equal to -2. Now we're ready to write the vertex form answer for this equation based on these 2 points. So a is -2, x minus h, so minus -2 is going to become +2 squared, and then k is -2. So this is our answer in vertex form. And if we keep doing math on this equation in vertex form, we will arrive at standard form. So y is equal to -2. So you want to work with the exponents first. PEMDAS is applying now. So x plus 2 squared is x squared plus 4x plus 4. Going to distribute to each. -2x squared minus 8x. -8 minus 2 is -10. And then here is my equation in standard form. All right, next problem. Guided practice. Look above into the examples. So look for guided practice 8a. And we have a vertex of 5, -1. And we have a point on the graph of 3, -5. Label everything. Vertex is h and k. A point on the graph is x and y. We're going to work with the vertex form, which is a x minus h squared plus k. Substitute these values. So -5 equals x is 3 minus h is 5 squared minus 1 is k. And do the math. 3 minus 5 is -2 squared equals 4. Add 1 to both sides. -4 equals 4a. A equals -1. Now I'm ready to write the vertex form equation. -1 x minus 5 squared minus 1. do the math again to transform this to standard form. X minus 5 squared FOILs into x squared minus 10x plus 25. Distribute the negative 1 to each term. Minus 25, minus 26. One more problem to go. Number 8, the vertex is 3, negative 2. A point on the graph is 0, 4. Label. Vertex points are H and K. You need to continue to write these base forms out because it absolutely helps you to memorize. Substitute these 4 values into this equation to solve and find out what A equals. Add 2 to both sides. 6 equals 9a. Divide by 9. A equals 6 over 9. Simplify. Divided by 3 equals 2 over 3. And now we can write that into our equation. H is 3 minus 2. Vertex form. Continue to do the math to get standard form. X minus 3 FOILs, x minus 3 squared FOILs to x squared minus 6x plus 9 minus 2. Going to distribute the 2/3 to each term. So this is 6 over 1 times 2 over 3. So it's going to be 12 over 3. 9 times 2 is 18 over 3. Minus 2 at the end. Simplify where I can. This is 4x plus 6 minus 2 equals 4. Here's my standard form. Next, I want you to turn to page 566 in your textbook. And right now we're going to look at 2 graphs. We're going to use a graph to make an equation. We did this in class, and it's the same thing as we just did, except we're going to look at the graph to figure out what the points are. So, page 566 in your textbook, and start with number 31. So looking at the graph, the vertex is at 1, 1, and a point. There are a couple of points to pick from. I chose 0, 3. And now this proceeds just like the other problems that we did. Y is 3 equals A times 0 minus 1 squared plus 1. Negative 1 squared becomes 1, so that's 1a minus 1a equals 2. Plug that into our equation. here's the vertex form. Keep doing the math. FOIL this binomial, and you get x squared minus 2x plus 1. Distribute the 2. This is going to be 2 plus 1 is 3. And here is the standard form. Last problem, looking at the graph for number 33, the vertex is at 0, 0. A point on the graph that I chose to work with is 1, negative 1. Label substitute into vertex form base equation. Negative 1 equals a times 1 minus 0 squared plus 0. Doing the math leaves negative 1 is equal to a. Substitute back in. So here's your vertex form. And then if we simplify this, we get negative x squared is our standard form. And that is all for today's homework.